In just 11 minutes, SpaceX proved Starship isn't just a prototype anymore. It's a revolution taking shape. On October 13, 2025, Flight Test 11 saw Ship 38 and Booster 15 lift off from Starbase, complete every objective, and mark the end of the Block 2 era. This wasn't about spectacle, it was about progress. Today, we'll uncover what happened during that flight, why these results matter so much, and how they redefine the future of human space exploration. The 11th integrated Starship test was designed to push technology to its limits while collecting hard data for future missions. SpaceX launched Ship 38 atop Booster 15 to 2 from Boca Chica's Starbase at 23:23 Universal Time Coordinated, with all 33 Raptor 2 engines firing flawlessly. That ignition alone demonstrated how far SpaceX has come since early prototypes struggled with engine timing. The ascent profile was picture-perfect, and this time, every sequence, from liftoff to stage separation, worked exactly as planned. One headline goal was the in-space Raptor engine relight test, a maneuver critical for future orbital burns and controlled returns from deep space. Ship 38 successfully reignited its Raptor in microgravity, validating software updates for ignition timing and fuel mixture under vacuum conditions. Engineers confirmed stable combustion and thrust alignment, key ingredients for lunar orbit insertion or Mars return trajectories. Another innovation involved the thermal protection system. SpaceX deliberately removed backup layers from certain heat shield tiles to measure true thermal loads during re-entry. This data reveals how much margin the vehicle really has and guides lighter, more cost-efficient designs. Meanwhile, Booster 15 tested a new multi-phase landing burn algorithm, first igniting 13 engines for deceleration, throttling down to 5 for trajectory control, then using 3 central engines for final stabilization above the Gulf of Mexico. Even though the booster was expended afterward, the telemetry captured fine-grained data on engine transitions and propellant efficiency. By combining these upgrades into one flight, SpaceX didn't just test hardware. It verified the system's ability to execute multiple high-precision operations within minutes. This was the cleanest ascent-to-separation performance in Starship's history, confirming that Block 2 has reached full maturity and is ready to hand the torch to the next generation. Re-entry has always been Starship's toughest challenge, but Flight 11 turned that into its biggest triumph. After coasting across the globe, Ship 38 began a banking re-entry maneuver designed to simulate the atmospheric return profile planned for future orbital missions. Tilting its massive flaps, the ship created aerodynamic lift and drag control simultaneously, allowing engineers to study how the craft handles real-world atmospheric turbulence. As the vehicle encountered peak heating, sensors captured data from hundreds of points across its stainless steel hull. This was the first time SpaceX intentionally exposed parts of the surface to higher than normal temperatures by removing some protective tiles. Despite that, Ship 38 maintained full structural integrity. The result, one of the most data-rich re-entries in company history, revealing exactly how heat loads distribute across the ship's complex geometry. Then came the controlled descent sequence. The flaps smoothly adjusted angle of attack, using real-time feedback from onboard computers to keep the ship stable as it transitioned from supersonic to subsonic speeds. Finally, Starship executed its flip maneuver and splashed down in the Indian Ocean with remarkable precision, roughly 1 hour and 6 minutes after launch. Meanwhile, the booster performed its own experimental landing sequence over the Gulf of Mexico. By igniting and throttling down engines and stages, SpaceX measured how each configuration affects stability and fuel consumption. Though not recovered, the booster achieved all its data objectives, validating the new landing algorithm. What makes this so important is that both stages met their targets independently, yet worked as a unified system. For the first time, Starship completed ascent, re-entry, and splashdown without a major anomaly. That success pushes SpaceX closer to full-scale reusability, a key step toward lowering launch costs and enabling frequent interplanetary missions. Flight 11 wasn't an ending, it was a gateway. With every target achieved, SpaceX officially closed the Block 2 chapter and began preparing Block 3 Starships, the first designed for semi-operational missions. These next-generation vehicles will feature improved heat shield materials, lighter stainless steel alloys, upgraded Raptor engines, and refined guidance systems informed directly by data from Flight 11. For NASA's Artemis program, this success is more than encouraging, it's foundational. The Starship lunar lander variant must prove it can safely reignite engines in orbit, endure high-energy re-entries, and perform controlled descents on other worlds. Flight 11 validated all three capabilities in one shot, significantly boosting confidence that SpaceX can meet NASA's 2026 to 2027 lunar timelines. Beyond Artemis, these results lay the groundwork for orbital refueling and deep space logistics. The engine relight data ensures future tankers can maneuver precisely in orbit. The heat shield results confirm Starship can survive multiple atmospheric passes without total refurbishment. Together, they unlock a path to true reusability, an economic game-changer for both commercial payloads and planetary missions. SpaceX also plans to incorporate this data into its Starlink deployment missions, testing cargo door mechanisms and satellite release systems similar to the 8 dummy payloads flown on Flight 11. That means every future Starship launch won't just test. It will do work, placing satellites or cargo while refining vehicle design. What makes Flight 11 remarkable is not just technical success, but reliability. It demonstrated that SpaceX's iterative design philosophy, fail, learn, improve, has reached a turning point where each mission delivers predictable, high-quality results. The dream of launching, landing, and relaunching massive spacecraft may soon move from concept to routine. Flight 11 proved that humanity's next step into the solar system will be built not on theory, but on tested, repeatable performance. Starship Flight 11 wasn't just another test. It was a statement. In 11 precise minutes, SpaceX demonstrated everything it's been working toward: reliable ignition, stable re-entry, and the confidence to evolve beyond the Block 2 design. The data gathered from Ship 38 and Booster 15 now fuels the creation of Block 3 Starships, the very vehicles that could carry cargo, satellites, and eventually humans to the Moon and Mars. The age of rapid, reusable spaceflight has officially begun. Starship Flight Test 11 wasn't just a test, it was a statement. In just 11 minutes, SpaceX proved that rapid iteration can reshape the future of space travel forever. To dive deeper, click the link to watch our full video and don't forget to like, share, and subscribe. Thank you for watching. See you there.